Informally proving that the limit as x approaches 4 of the quantity x cubed minus 4x squared plus 3x equals 12, we're going to let epsilon greater than 0 be arbitrary, and we need to choose a delta that equals the minimum of epsilon over m comma 1, and we're going to determine m. So as we look at this problem, we're basically saying we're given this epsilon greater than 0, and we want to choose a delta such that if we had the absolute value of x minus 4 less than delta, that would imply the function, I'm just going to put it as f of x minus 12, would be less than epsilon, this being our f of x. So we're going to start with that piece of information. We're going to take our x cubed minus 4x squared plus 3x minus 12 less than epsilon, and let's go ahead and factor this. Now it's got 4 terms, so that leads me to try factor by grouping. I'm just going to put that below. So I'm going to factor an x squared out of the first 2 terms, leaving an x minus 4, and then a plus 3, leaving an x minus 4, and that's still inside of absolute values less than epsilon. And now I'm going to complete that factor by grouping. So I have x minus 4 and I have x squared plus 3. And that absolute value is less than epsilon. Now in looking at that, I can see that this is always positive here. So I'm going to just write x squared plus 3 and then put absolute values around the x minus 4. And then less than epsilon. Now I am going to consider if delta equaled 1, and I'm going to take that absolute value of x minus 4 then and set it less than or equal to 1. And as before, our motivation for that is we know that if we multiply some positive quantity less than 1 to some other factor, it becomes smaller. Okay, so as we write that out without absolute value signs, we have negative 1 is less than x minus 4, which is less than 1. Solving for x in the middle, adding 4 everywhere, that would make a 5 here, and adding 4 here would make this a 3. And next thing we're going to want to do, because we have this factor here, x squared plus 3, we want to utilize what we have here to see how we could replace x squared plus 3 with a number. We're trying to find a bound for x squared plus 3. So the first thing I'm going to do is I'm going to square everything, because this inequality will be preserved when I do that. So this will be 9 less than x squared less than 25. And then the next thing I'm going to do is add 3 to everything. And the reason why is I'm trying to get the middle to look like this, because then I'd have a lower bound and an upper bound on x squared plus 3. So adding 3 to everything, I would have 12 is less than x squared plus 3 is less than 28. So now I have bounds for x squared plus 3. I'm only interested in an upper bound because I'm just interested in a number that I know this would be less than. And so I am going to replace this x squared plus 3 with 28. And when I do that, this inequality will hold because this x squared plus 3 has to be less than 28, so I know that it's going to be even smaller than it was if I replace that with a 28. So I'm going to have 28 times that absolute value of x minus 4 needs to be less than epsilon. Now I'm going to solve for the absolute value of x minus 4 by dividing by the 28. And so now I have, that's my e over 28, and that's my other delta. Now the way they asked this particular problem, they've already given us this format, and so we need to just simply put in 28.